In weeks 5 practice, you're going to practice some problems dealing with two-step equation word problems, linear equations with variables on both sides, and linear equations with parentheses, which will also have variables on both sides. So for the first question here, Mary has a job that pays her $8 per hour plus tips. This past week, Mary earned $311 total, and $55 was in tips. How many hours did Mary work? So take a moment to figure that out and put your answer in, and then we'll go through it. So for this, starting out very generally, I know that the total pay is going to be $8 per hour times the number of hours that she worked plus the money she earned in tips. So very general format here, and the $8, of course, is dollars per hour. Um, they're giving us some of the information. What we're looking for is the number of hours that she worked. So this part right here, the number of hours she worked, is eventually going to get replaced with X. So I got to get some other things to fill in here. I mean, I have a number for her rate. I got to put a number in for her total pay, and I got to put a number in for her tips. Now, luckily, those two things are given pretty readily. Her total was $311. Her tips were $55. So all I need to do is replace the appropriate things with those. So 311 would equal 8x, because again, x represents the number of hours she's working, and you can let any letter you want be the variable, plus 55. So this would be a two-step equation to solve. So I would first subtract 55 from both sides, and I would end up with technically 256 equaling 8x, but I prefer to have my variables on the left-hand side as a personal preference. Therefore, that's the way I wrote it. So 8x equals 256, which is the same thing. I would then divide both sides by 8, and I would end up getting that x was equal to 32. And since x represents the number of hours she worked, and that would answer the question, Mary worked 32 hours this past week. On to the next problem. In this question, you're given that Gino's Pizza has pizzas for $9 each and wings which cost $7 per dozen. They also charge $4 for delivery. Kate placed an order for a party that she was having at her house. She ordered pizzas and 4 dozen wings. The total of her delivery order was $131. How many pizzas did Kate order from Gino's Pizza? So take a moment to answer the question and find out how many pizzas she ordered, and then we'll go through it. So for this one, there's a lot of things going on here, and it seems at first that there's a lot of different variables, but as the problem goes on, the information for those gets told to you. So in general, though, I'm going to be working with a very general formula here that the total cost for her delivery order is going to be the pizza cost plus the wings cost plus the delivery cost. So there's 3 costs being mentioned here. Now some of them are related to the number of the products that she's purchasing, and one's just a flat fee. So when I break this down further, the total cost is going to equal the number of dollars per pizza plus the number of pizzas. And that's going to give you the pizza cost, plus the number of dollars per dozen wings times the number of wings, which will give you the wings cost, plus the delivery charge, which is just a fee for delivery. It's charged once per order. So now what I have to do here is figure out which of these pieces of information I know and which is it that I'm looking for. So when I break this down, I know the number of pizzas. That's why it's highlighted in this green color, which matches this color down here. I know the cost per dozen wings, which corresponds to this color down here. I know the delivery charge, which corresponds to this color down here. I know that she ordered 4 dozen wings. So, and this really should say per dozen wings, because it's still based on dozens. But you got the idea. So this is going to be replaced with a 4. The thing I don't know is how many pizzas, this orange part right here. And that's what I'm going to replace with the letter P. So the equation I come up with initially is 131 equals 9p plus 7 times 4 plus 4. which doesn't look like a two-step equation, but it's just basically a two-step equation as far as solving goes. I just have to simplify that right-hand side a little bit. I had to do what 7 times 4 is, add that to the 4, and I would end up with 9p plus 32, which was originally on the right, but I'm putting it on the left because my variable's there, and that's going to be my total charge of $131. Now I want to solve this for P because P represents how many pizzas Kate ordered. So I'm going to subtract 32 from both sides. And when I do that, I get that 9P would equal 99. I would then divide both sides by 9 and end up at P equaling 11. So that means that in this overall order, Kate ordered 11 pizzas from Gino's in this order here. Now the rest of these are just going to be dealing with equation solving techniques that go a little bit beyond just a two-step equation. Ultimately, what you're trying to do is get it down to a two-step equation, but in some cases they're simplified. Sometimes there's a little bit more manipulation. So let's have a look at this first equation. So 3x plus 21 equaling 7x minus 11. Take a moment to solve that, and then we'll go over it. When you solve equations like this, one of the key things you want to do first and foremost is make sure that each side is individually simplified. That means if there's any like terms, any operations to carry out, I should do those first. And right now, 3x plus 21, there's nothing more to do with that on the left-hand side. And 7x minus 11, there's really nothing to do with that on the right-hand side. So what I want to do now is get x alone on one side of the equation only. So I want to isolate that x and end up with x equaling some number, which would be my solution to the equation. So the first thing I always try to do is, once I know that both sides are simplified, is I try to get the variable on one side. So I'm either going to eliminate the 3x from the left-hand side, or I'm going to eliminate the 7x from the right-hand side, and end up, getting the variable just on one side. Since I prefer to have it on the left-hand side, I'm just going to subtract 7x from both sides. And then I end up with, on the left-hand side, the 3x minus 7x becomes a negative 4x. I still have the plus 21. On the right-hand side, the 7x minus 7x cancels, and I'm left with a negative 11. Always be sure to keep track of your signage, because if your signage, you have to make sure that you're attaching it to the right number and not eliminating it when it shouldn't be eliminated. So now I have a two-step equation. So I'm going to subtract 21 from both sides. And that's going to give me negative 4x equaling negative 32. I would divide both sides by negative 4 to get x alone. And I would end up with x equaling 8. Of course, you could always check these as well. And that's one of the good things when you're just doing equation solving, is that you are checking them to make sure they're right. So if I just plug the number in, do I get the two sides to be equal to each other? Does 3 times 8 plus 21 equal 7 times 8 minus 11? So 24 plus 21 is on the left, 56 minus 11 is on the right. 24 plus 21 is 45, and so is 56 minus 11. So the number 8 for x does make this equation hold up, so that is the solution. The next one's a little bit more complicated, because this one actually does require some simplification first. So with that hint in mind, take a moment to solve it, and then we'll go through it. Okay, so on the left-hand side, I have some x terms that can be combined, and I have on the right-hand side some x terms that can be combined. So I'm going to do some simplifying for that to happen. On the left-hand side, the 18x minus the 6x becomes a 12x, so I end up with 12x plus 1. And on the right-hand side, the 2x plus 10x becomes a 12x, and the plus 3 just stays plus 3. Now, at this point, you may recognize what the answer is, because if you think about it, well, if I do 12 times the number and add 1, and do 12 times that same number and add 3, how could they possibly be equal to each other? I mean, even from that kind of standpoint, it doesn't really make a whole lot of sense. And some people may notice it here, and that's fine. But if you don't notice it, carry through the rest of it, because my next step would be to try to get the variable isolated on one side. So I say, okay, well, I want to get rid of the 12x on the right-hand side, so I'm going to subtract 12x from both sides. It just so happens when I subtract 12x from both sides, it also cancels on both sides. So I get a situation where the variable, when I go, the variables cancel and goes away completely whenever I'm using the process to solve it. That's a sign that I have a special case, and there's two special cases. One special case is that there is no solution. The other special case is that there are infinite solutions. And when I look at this situation here, I have a special case, and I end up with the equation that 1 equals 3, which we know is a false statement. 1 does not equal 3. And so since I know it's a special case, and the statement I end up with is a false statement, this means that the equation has no solution. So no matter what value of x you would pick, it would never work for this. It's never going to happen. So on to the next one. Solve this following equation, which has some similarities to the last one, but it's not identical. So carry this through and see if you can come up with an answer. Okay, so again, on this one here, there is some simplifying I need to do on both sides of the equation. And I see that I do have some like terms, so I'm going to combine some like terms. On the left-hand side, the 18x minus x becomes the 17x, and the plus 2 sticks around. On the right-hand side, I have 2x plus 10x, which is 12x, and I have a 13, which sticks around. So the equation becomes 17x plus 2 equals 12x plus 13. So now I go through the remainder of the steps here. I want to get the x's or variables on one side of the equation. So I'm going to subtract 12x from both sides. I like having them on the left. And so on the right-hand side, the 12x's are going to cancel. On the left-hand side, 17x minus 12x is going to be 5x. So I have 5x plus 2 equaling 13. I would then subtract 2 from both sides, and that would give me 5x equaling 11. And then I would divide both sides by 5 to get that x equals 2.2. I chose to check this because originally I wanted to try to set this up so I would get a whole number answer. I was like, and when I set this up, I was like, okay, it didn't come out to be a whole number, and I wanted it to be, but 2.2 is not a bad number to come up with. So I did run a check on it just to be on the safe side, just to make sure that is the answer. And so I just plugged the 2.2 in for all the x's. On the left-hand side, I end up with 39.6 plus 2 minus 2.2. On the right-hand side, I end up with 4.4 plus 13 plus 22, which on both sides becomes 39.4. So the two sides do equal each other. They both become 39.4 when x equals 2.2. So that is a correct solution, and that's how I can verify it. So anytime you get an answer that just seems like it's a little bit off kilter, by all means, check it to see if it works. Which is why oftentimes you're going to be asked in these practices that you're going to be doing, or these quizzes that you're going to be doing, to do situations where you show your work and not be given necessarily multiple choice items. Because ultimately, multiple choice items, you don't have to do any of this stuff here on the left, any of this stuff over here, because if you're given, possibilities for x, ultimately all you really have to do is just check them. If they're multiple choice items, you just plug the number in and see which one gives you a true statement when it's done, which one makes both sides of the equation equal to each other. So all these steps over here, which is what the actual algebra is, you don't necessarily have to do that if it's a multiple choice item. That's why I'm not a big fan of multiple choice items with this, and which is why when you do the Keystone exams, they always do have some equation problems where they do want you to show your work just to show that you know the technique and don't just know how to plug the number in and check to see if it works. So, although that's an important skill too. So this one here, another one very similar to the last several we've done. So take a moment to solve this and see how you do, and then we'll go through it. So for this one here, on the left-hand side, it's already simplified, which is good. On the right-hand side, it's not simplified. So I do want to simplify first and combine those like terms. So the left-hand side is going to say 4x minus 17. On the right-hand side, the 2x plus 3x becomes 5x. So I have 4x minus 17 equaling 5x minus 72. Now that each side is as simplified as it's going to get, I now work on isolating the variables. So I want to get my x's all on one side. I'm going to choose to subtract 5x from both sides, so I get my variables on the left, and any variable on the right is going to cancel at that point. So I'm going to end up with negative x minus 17 equaling negative 72. Again, that's not the only way you could do it. You could have also chosen to subtract 4x from both sides, and you would have, I mean, you would ultimately get to the same correct answer I will get to. Just some signages might be different, some coefficients and things might be a little different along the way. So keep in mind there's more than one way to approach this problem. It's just my personal preference that I like having my variables on the left. So now I have my variable on the left only. I just have to get rid of the things that are attached to it, namely the minus 17 and the negative symbol in front of it. So I'm going to add 17 to both sides first, and I'm going to end up with negative x equaling negative 55. Now, I mean, if negative x equals negative 55, it's not a big leap of logic to say that positive x would equal positive 55, or just x equals 55. But technically, you know, if you're using operations as such, that negative 1 is being multiplied to the x. And there are two ways to get rid of a negative 1. I mean, if I was going by operations specific, I would divide both sides by negative 1, because I should be dividing to get rid of a multiplication. But because 1 is its own, basically, inverse, as well as its own identity, you know, multiplying by negative 1 will also get rid of a negative 1 as well. So that's what I chose to do on both sides. And then that gives me that x does equal 55. So now in the next equations we're going to be doing, you're going to see instances where we're actually have parentheses. And the procedure is not much different. I still need to simplify. It's just how I simplify is going to be altered a bit. So let's have a look at this following one. So for instances like this, if I had parentheses on just one side, I would have a couple of options, because I could either choose to distribute to get rid of the parentheses, or I could just like leave the grouping as it is and just realize, okay, to get rid of the parentheses, like for instance, if I wanted to get rid of the parentheses on the left, I would divide both sides by 3, and that would naturally make them drop off. That doesn't help in this one so much, because in this one, if I divide both sides by 3, yeah, I could drop the parentheses on the left-hand side, but now I have, instead of a 7 in front of the parentheses on the right, I have a 7/3, which is a little bit even more complicated to eliminate. So when I have these situations like this, I mean, it still has variables on both sides, but now I have parentheses involved. So when I deal with situations like this, I mean, what I'm going to do to simplify is I'm going to carry through some distributive property. So on the left-hand side, the 3x plus 5 gets multiplied by 3, which becomes 9x plus 15. And of course, a common error that students make with this is that they sometimes forget to distribute properly. They multiply the first term by what's on the outside, then forget anything that follows. So that's a very common error in that kind of situation. So for the next one, on the right-hand side, I multiply both sides by 7. I I distribute the 7 on the right-hand side, I should say, and I get 7x plus 21. So now I have the type of equations that I had in the previous examples, where I just have variables on both sides. So they're already simplified, so I don't have to worry about simplifying any further. Sometimes you may have to simplify further. So I'm going to now subtract 7x from both sides in order to get the variable isolated. So on the left, I'm going to have 2x plus 15. On the right, I'm going to have 21. And now I'm going to subtract 15 from both sides to start getting the variable isolated. So when I do that, I'm going to end up with 2x equaling 6. And then I'll divide both sides by 2 to get that x equals 3. And of course, I mean, I can still do a check with this as well. As I said, I'm not doing it with all of these because, you know, the fact I'm giving you the right answer is kind of your check. So here, I just simply put the 3 in for everywhere I see the x's, and I carry it through, and I get eventually that both sides do equal 42, which verifies that that x equals 3 is in fact the correct answer. So I'm good there. Now let's try it for the next one. So again, now one of the things that I want to speak about really before we get into this is for me to solve this equation, obviously, again, I had to get rid of the parentheses. And the reason being is anything inside of a parenthesis cannot be moved or manipulated until the parentheses are gone. So sometimes students will mistakenly look at this and say, well, I'm going to add 7 to both sides. That doesn't work here because technically you're not really subtracting 7 on the left-hand side. Since that minus 7, like the x, is being multiplied by 4, you're actually subtracting 28. Which we'll see a little bit more when we do our simplification. So when students will sometimes just, and I'm going to add 7 to both sides, and they put it, no matter where they put it on the right-hand side, either outside the parenthesis or inside, it still ends up being wrong because that's not what's being subtracted technically on the left-hand side because, as I said before, that quantity is being multiplied by 4. So basically anything inside of a grouping symbol cannot be, eliminated from one side or the other until the parenthesis is gone. Now, I could either divide both sides by 4, for instance, to get rid of the parenthesis on the left-hand side, but that's going to make things worse on the right-hand side. And then, so for this kind of instance, the best thing to do to get rid of the parentheses is to distribute the 4 on the left and distribute the 10 on the right. So as part of the normal simplifying process for this, I am going to distribute the 4 on the left, and I'm going to distribute the 10 on the right. And when I do that, I get 4x minus 28 on the left, I get 10x minus 10 on the right. Now, both sides are now completely simplified. So now I work on getting the x on one side of the equation only. And since I prefer to have them on the left, I'm going to subtract both sides by 10x. You also have the option of subtracting 4x from both sides and having the variable on the right. Not a big deal. I know how to handle it that way, but it's just my personal preference, and I like having it on the left. So 4x minus 10x is a negative 6x, so the minus 28 is still there because nothing changed that. On the right-hand side, I'm left with just a negative 10. Now I have the x on one side of the equation. Now I got to get it isolated. So I have a multiplication of negative 6 attached to it. I also have a subtraction of 28. Of those two, the subtraction of 28 needs to go first, so I add 28 to both sides to get negative 6x equaling 18. I then divide both sides by negative 6 to get that x equals negative 3. Now try this next one. As it was before, I want to get x alone on one side of the equation, but I have x's inside parentheses here, and those parentheses being multiplied by something. So I'm not able to move any x's from one side to the other or isolate anything as of yet because of all these parentheses. So as part of the simplifying process, I'm going to distribute the 6 on the left, I'm going to distribute the negative 3 on the right. So when I do that, I end up with, on the left-hand side, 12x minus 48, and on the right, I end up with negative 48 plus 12x. Now, if you're looking at this and realize, well, 12x minus 48 and negative 48 plus 12x are the same thing. So, what does that mean? I'm basically saying that 12x minus 48 equals 12x minus 48, and any x value would make that happen. But if for some reason you don't observe that immediately, if you carry through the rest of the procedure, you will reach a point where that same conclusion has to be made. So let's see that happen. And again, I would be trying to get the variable on one side of the equation. Now, it just so happens I have the same thing on both sides. So whether I'm trying to get everything on the left-hand side or get rid of everything on the right, or vice versa, I would still do the same thing. I would subtract 12x from both sides. And as a result of that, on both sides, the x's cancel with each other, and I'm left with no more variables. So the variables cancel completely. And as we talked about before, when the variables cancel completely, I have a special case for this equation. And the two special cases that you have for a linear equation is either I have no solutions or I have infinite solutions, where any value would work. So how do I tell, looking at this, which one of those is the case? In the examples that you see from Khan Academy, they always take it to be equal to 0, so they would actually do one more step and add 48 to both sides and get 0 equals 0. But once the variables cancel, you know it's either going to be no solution or infinite solutions. And before, when we showed a situation where it ended up being no solutions, because what we ended up with once the variables cancel was a false statement. This one here, negative 48 equaling negative 48, is a true statement. And because the variables canceled, giving me a special case, and me ending up with a true statement, that tells me that the equation has infinite solutions. So this one here has infinite solutions, which means that any value of x that you would pick would work. So one last example for you to practice, and that's this one here. So take a moment to solve it and see what you can come up with, and then we will go through it. So this one here, I have actually two sets of variables on the left and one on the right. So I have multiple variables. I have actually multiple parentheses on one side. So I am going to do some simplifying with this before I reach a point where I can solve the equation for x and get it alone on one side. These parentheses have to go. So I'm just going to carry it through the distributive property for all three of these sets, being mindful of what the signage is. So the first group, I'm going to distribute the 8 to the x plus 5. That gives me 8x plus 40. For the second group, I have to be careful with this. I am distributing a negative 4. Some students forget about that little negative sign. And that's going to give me a minus 4x plus 12. A lot of students will put a minus 12 there. That is if they even remember to distribute to the second term. And then, of course, on the right-hand side, I end up with 11x minus 11. I'm not done simplifying yet because the left-hand side, I have multiple like terms. I have 8x and a minus 4x, which are variable terms, and I have 40 and 12, which are constant terms. And I can combine those together. So through doing some more simplification, 8x minus 4x is 4x, 40 plus 12 is 52, so I end up with 4x plus 52 equaling 11x minus 11. Now each side is simplified. Now I can start working on getting the x's on one side of the equation only. And again, because I like having my variables on the left and I don't like them being on the right, I subtract 11x from both sides to essentially get rid of them on the right and get them all on the left. So 4x minus 11x gives me a minus 7x plus 52 equaling negative 11. I would then subtract 52 from both sides to get negative 7x equaling a negative 63. And I would then divide both sides by negative 7 to get the final answer of x equaling 9. And that is the end of this practice. If you have any additional questions, please make sure to contact me. If you understand this, please move on to the quiz for this week and see how you fare with that. And if you don't have too many problems with that, then you're good. If not, you may want to go to Khan Academy and see if you can find some additional resources to get some additional practice. But by all means, reach out to me if you need additional help as well. Until next week, when I make another one of these videos, I will see you around. Have a good day, and get in touch with me if you need any help. Bye, everyone.